Hello, we are the Puppy Pie. We're going to present our progress. This subject is design and implementation of mechatronic systems. My name is Patricio Macias Valadez,
My name is Agustín Esbigel.
I'm Manuel Alonso.
I'm Alfredo Vázquez.
and we are 8th semester students.
Well, as a track, we use an F1 type circuit to test the ability of control and the Puppy Pie to test the in curves. We also use an MDF base to reduce the friction it has on the floor, and also using craft paper, we create some walls so the LiDAR could give us a distance between what we have in the track.
The vision system runs on the laptop using a live video stream from DroidCam. A Naruko marker attached to the Puppy Pie is detected to estimate the robot's position, heading, and orientation relative to the track. A predefined trajectory is loaded as a reference path. The system continuously selects forward reference points along the trajectory and computes real-time forward, lateral, and angular errors for navigation. Future trajectory points are also analyzed to anticipate upcoming turns. The software automatically detects straight sections and curves, allowing the tracking behavior to adapt dynamically. Straight sections use smoother motion, while curves use faster corrective responses. The interface displays the desired trajectory, robot position, heading, and target point in real time for visualization and debugging. Finally, all the navigation errors are transmitted through UDP communication to the Raspberry Pi, where the PID converts them into movement commands for the robot.
So for our PID controller, we are using a classic PID. Our Raspberry Pi receives the forward, lateral, and angular error. This helps us to continuously maintain the trajectory error, minimization, and to direct correction. Also to maintain forward movement. The result is that the Puppy Pie is able to autonomously follow a preload trajectory using computer vision. Inside the PID program, we have three different protocols. The first one is spin mode. Is for when the curves are too straight for the puppy to just outcome them. So the puppy stops and starts spinning around until it finds the correct angle. Then there is the fan light mode that help us when the curves are not as big, so we can just correct the walking of the puppy to maintaining the line. Then we have the forward mode that help us to when the lines of the track are straight, so it doesn't lose the center. We also got a leader that helps us to avoid obstacles and a signal filtering system. Also, we validate all the vision data before using it and the speed and yaw limits to reduce faults.
Okay, now moving on this next part, we have the LiDAR integration for the Puppy Pie. We use this sensor mainly for obstacle repulsion and collision avoidance. As you can see at the Puppy Pie, we have the LiDAR and this continuously scans at 360 degrees area around the robot. If the robot gets so close, the papercraft walls or any object, the system performs a reactive correction. This means it instantly modifies the trajectory. This works together with our PID assistance navigation, so the robot can smoothly recalculate its path and keep them moving forward without crashing or maybe stopping.
Finally, we have our results, what we obtained working on the Puppy Pie. On our best attempts, we just get 2 bounds out of the track. It's where one of the legs of the puppy stand out of the delimited track. But we also obtain a 2.17 centimeters average error, which means we are centrally pretty much average between the desired track and what the puppy is doing. And we also fulfill the track in 5 minutes and a half. We also use a current sensor in order to measure how much current it's actually taking the Puppy Pie to fulfill the track in order that we could use it as a guidance for efficiency.
Finally, with the strategy for the future improvements, First, we need a newer battery to keep the stable voltage for the Raspberry Pi because the robot consumes a lot of energy. Second, we want to adjust the spin kinematics to achieve zero collisions and lower the maximum error by 2 centimeters. To the end, we need to improve outdoor friction. We plan to design a puppy traction shoes, basically rubber grips, so the feet won't slip on the MDF base. And this is all. Thank you.